Hi, my name is dr. Ahmath. Welcome to this lecture. In this lecture, we're going to talk about the operations with the numbers and especially operations with the rational numbers. So previously, we discussed about the numbers and we defined a couple of sets, which are really important for us. So R is going to be the set of real numbers. And for example, example of the real number might be 2.13, right? So we said that any number which is presented on the number line is going to be a real number. And a rational number is going to be any number which is presented in the form of P over Q, where P and Q are the two integers. It might be like a 2 over 3 or minus 5 over 10, or like a 2 over minus 3, for example, right? And the whole numbers, the integers, right? So integers are the whole numbers. They might be minus 5, minus 10, 11, 237, for example, right? And the natural numbers are the positive integers, positive whole numbers. So any number which I can count, right? Starting from 1, it's going to be a natural number. 1, 2, 3, 4, 5, 6, 7, and so on. So this is going to be, they are going to be the natural numbers. So today we're going to talk about mostly on the operations with the ratios. So before we do this, I would like to go a little bit more deeper to try to understand physically what does it mean, a ratio. So in order to do this, I'm going to talk about a little bit about the laws of signs. So law of signs. So on the number line again, so let me draw the number line. So here I've got a 0. On the more righter side, from the 0, we're going to have a positive numbers. Positive numbers, we usually denote them as a 1, plus 2, plus 3, and so on. And on the left side, we're going to have a negative numbers. Okay, so let's say it's going to be minus 1, minus 2, minus 3, or any real number which is more lefter than 0. It's going to be a negative number. So we can make a official definition as well. So a negative number, any number more lefter than 0 on the number line. So the similar definition can be done for positive numbers. So any number which is more righter than a 0, it's going to be a positive number. So for us, it's important to know. So if you've got two numbers, one from the negative side, one from the positive side, what are going to be the results of some operations with these two numbers? So let's say I've got x from here. So a negative number. So I'm going to say that x is going to be a negative number. And previously we talked about the variables as well, right? So x here is going to be a variable which can take different values under this constraint. So this is going to be our constraint. It means that it should always work. It should take always a negative number. I can take any number, but it should be negative. So now here, let's say y is going to be a positive. So y is positive, right? Again, y is our variable. It can take different values starting 0, any real number, but the only constraint is that it should be a positive number. So what I would like to try to understand is I would like to try to know what if like I would add x and y, what is going to be a result? Is it going to be a positive or negative? So well, it appears, I don't know, right? So if you've got a positive number and a negative number, and if you add them, sometimes you might get a positive number, sometimes you might get a negative number. So the answer is not defined. So we can't really say that this is positive or negative. For example, x might be minus 4 and y might be 3. Then in this case, x plus y, it's going to be minus 1. At the same time, you can assign x to be equal to minus 4, but y is going to be like a plus 8. right? So in this case, x plus y is going to be plus 4, which is a positive number. So sometimes it's going to be a positive number, sometimes it's going to be a negative number. But what if I'm going to subtract them, right? Well, in this case, it depends like which number is coming first. So this is the first question. So we're going to talk about the second question. Let's say x minus y, right? So in this case, x is a negative number, negative. So minus y, so y is positive. If I multiply this as a minus, it's going to be a negative. It's going to be, again, a negative number. And the sum of two negative numbers, negative plus negative, is also going to be a negative. So the answer is a negative. Okay, so negative plus negative is a negative. Positive plus positive is also going to be positive, but positive plus negative is, we don't know. Okay, so in this case, so let's say x is going to be minus 4, y is going to be like plus 3, right? Plus 3. So in this case, x minus y is going to be minus 7. We can try with the second example, like x is equal to the minus 4, y is equal to the 8, and then x minus y is going to be minus 12. Okay, so it's always going to work. Okay, so we're going to talk about one more thing later on. So now, if I just put them together a little bit in a different form, like a y minus x, then what's going to be result? So the result is going to be a positive number, right? Because we know that if y is positive, so x is negative, but if I multiply this to the minus 1, if I take it minus x, it's going to be positive as well. Then if I just add the two positive numbers, we're going to have a positive number. So the result is positive. Good. So we are going to check this for these numbers again. So let's say x is equal to the minus 4, y is equal to the 3. What if like a 3 minus 4, right? It's x, y minus x. That's going to be plus 7, right? So if x is equal to the minus 4 and y is equal to the 8, then in this case, okay, then in this case, it's going to be like 8 minus 4 plus 12. Again, a positive number. Okay, so in mathematics, so lots of the time, you're going to see the questions like a true, false questions, true, false questions. And it's really important for us to understand how to define what is defined as a true and what is defined as a false in mathematics. Because in the languages, for example, in English, it's slightly different. So if there's a statement which is true always, if there's a law which is true in English, there might be some exceptions, right? In mathematics, it is not like this. So if there is a rule which is true, it should work always. Okay. For example, I may make a statement. So the statement, and my statement is going to be like a let x and y so are two real numbers. So let's say x is a negative number, y is a positive real numbers, are two real numbers. Then my statement is going to be like this. So x minus y is negative. It's my statement. I would like to know whether this is true or not. So actually, this is true, right? So we know that x is negative, minus y is also negative, right? So their sum is going to be a negative. This is true, okay? So this is true means that it is going to work. So this rule that x minus y is negative is going to work always for any value of x and y. So true means it works always. So at the same time, let's make another statement. Let's say x plus y is positive. Okay, so I've got one negative number, one positive number. I'm gonna add them, and I would like to know whether the sum is positive. So this is my statement: x plus y is positive. So is this statement is true or false? Okay, so we did this before, so we know that this is false. Okay, so while true means that this is going to work always, false doesn't mean that it doesn't work. It doesn't work always. Okay, so x plus y is positive is false. It doesn't mean that this is always false. Okay, always is not correct. It means that there are some cases where it is not correct. Okay, so it means there are some cases. There are some cases, or at least one case, when it doesn't work. Okay, because we know that sometimes it works, right? So if, let's say, x is a negative number, it's going to be -2, y is 10, for example. Then if you add them, like x -2, let me write this, -2 plus 10 positive, it's going to be +8. This is positive, right? So it works, but it doesn't work always. There are some cases where it doesn't work. For example, x might be equal to the -2, but y can be equal to the +1. So in this case, x plus y, which is -2 plus 1, it's going to be -1, right? So in this case, its result is a negative number. So in mathematics, if a statement is false, it means that there exists only one case, or at least one case, where it doesn't work. So it's really easy in math to prove that a statement is false, because we just need to figure out one case where it doesn't work. And at the same time, it is super difficult to prove a statement which is true, because we need to prove that the statement is true always for 100% cases, not like 99.99 cases, percent of the cases. It's going to work in 100% of the cases. Only in this case, we're going to say that the statement is true. So here we talk about the numbers, the positive numbers, negative numbers. We talk about the low signs when we are going to add or subtract these two numbers, but at the same time, there are a couple of rules where of rules of lows about the multiplication and division of the positive and negative numbers. So let us continue. So low of sign, lows of sign. Okay, so what we're going to do is like this. So let's say let x is again a positive number and y is a negative number. Then the multiplication of the positive to the negative, it's going to give you always a negative. So the multiplication of positive to the negative is negative. Okay, so positive to negative is negative. Okay, at the same time, we can just multiply a positive to the positive. For example, in this case, like y, or x to the x. Positive to the positive is a positive. Okay, so let us write positive to positive is positive. So negative to the negative is as well a positive. So y times y, it's also going to be a positive. So negative to negative is positive. Okay, and then one more thing is like if you divide, so for the division, we're going to have the same thing. So if you just like substitute the multiplication with the division, we're going to have the similar lows. Basically, x divided to the y, it's going to be a negative. So positive to the negative is always negative. So like a positive to positive is positive, right? So in this case, I know that it's going to be 1. So positive. So negative divided to the negative is also going to be a positive number, right? Okay, good. So here are some rules which are really important for us. So the lows of signs for the multiplication, division, and the addition. So some operations with the numbers, with the real numbers, which are really important for us. At the same time, it's super important for us to understand the operations with the ratios. So in order to do this, let me explore, let us try to understand what does it mean, the multiplication of a number to another number, or dividing the number to another one, okay? So basically, so if you've got an apple, okay, so let's say this is A. So if you add to your basket another apple, so you're going to have 2 apples. So let's say I've got a basket here. So if I just add here another apple, so let me denote this with the B, okay? Then I'm going to have 2 apples, okay? So this is physically, what does it mean? Addition, okay? I've got a basket, so X plus Y means that you've got a basket with X items, you're going to add extra Y items, okay? Or you're going to subtract Y items. But what I would like to try to understand is what happens when I multiply an apple to another number. So let's say I've got an A, okay? And if I multiply this A to the 2, what happens is that I'm not making my apple to 2 apples. So if I multiply apple or my variable to some constant A, what I'm going to do is I'm just going to scale this. I'm going to make it twice bigger in this case. So it's going to be like after the multiplication, it's going to be twice bigger apple. Okay, so if I multiply apple to the 3, that's going to be an apple which is 3 times bigger. Okay, so the multiplication, what it does is it scales your numbers. For example, if you've got an X, and if you just multiply this to the 3, what it does is it makes your variable X 3 times bigger. Okay, it's really important. And at the same time, division is the same. Like if you've got like a really huge apple, like, so this is your apple, and if you just divide this to the 3, what it does is it just scales this. It just makes it 3 times smaller, okay? So it's really important for us to understand this physically. So the what does the multiplication and what does the division? Because we are going to talk about the operations with the ratios, operations with the ratios. Right, so we've got the rational numbers, which are going to come in the form of P divided to the Q, okay? At the same time, actually, it basically tells us, hey, how I'm going to divide a P to the Q, right? Good, so let's say I've got 2 numbers, P and Q, and A divided to the B, okay? So I'm going to talk about the 2 important operations, like one is going to be addition, second is a multiplication. So I can add these 2 ratios if their bottom sides are the same. Oh, that's not really convenient to say the upper side and bottom side, right? So let us rename them. So always in your ratio, the bottom side, so this number which is in the bottom is going to be called as the denominator, and this side on the upper side is going to be called as a numerator. Okay, so I've got a rational number, so numerator over denominator, or okay, so the P divided as a Q can be also said as a P over Q. Okay, for example, like a 2 divided as a 5 can be said as a 2 over 5. Oh, just like introducing the notation, right, of the ratios. Good, so I've got a rational number which has a numerator and denominator. If I would like to add 2 rational numbers, their denominators should be the same, it appears. So let's say if I would like to have like a 2 divided as a 5, right? Plus 3 divided as a 5, okay? Then I can add them, okay? We can add them. So the rule is going to be in this way. So the first case, denominators are the same, okay? So if the 2 denominators of the 2 rational numbers are the same, then we can add them, and the result is going to be like this. We're just going to add the numerators, and the denominators is going to be the same, okay? So it's going to be 2 plus 3 divided to the 5. Or 5 divided to the 5, which is equal to the 1. Okay, so let's do another example. Let's say I've got 6 divided to the 5 minus 13 divided to the 5. So what I'm going to do is, again, so I can write down this slightly different because we know the addition, right? So minus 13 divided to the 5, for example. And in this case, so the two denominators are the same, so I can just add the numerators and use the same denominator. It's going to be 6 minus 13, which is minus 7 divided to the 5. This is going to be the result. So it's more important for us to know how to add the two ratios if the denominators are not the same, right? So the second case, denominators are not the same. So what to do in that case, right? So let's say I'm going to add 2 divided to the 5 to the, let's say, 5 divided to the 3. Okay. Or 2 divided to the 3. Good. So in this case, two numerators are the same, but still I can't add them, right? So we can add them only if their denominators are the same. And what we need to do is we just need to add the numerators. So now the result is not going to be 4 over 8 or like a 2 over 8 or anything like this. What I'm going to do is I need to use always the first rule. So I can add the two rational numbers only if their numerators are the same. So let me write this as a rule. Two ratios with the same denominator can be added only. Okay, good. So what if your ratios do not have the same denominator? We need to create, we need to make them the same, right? So we need to create kind of common denominator. So we're going to write down this ratio in a form where both of them are going to have the same denominator. Is it possible? Yes, unless we say yes, we can do this by just multiplying both of the numerator and denominator to the same number. For example, so the 2 divided to the 5 can be written as, like, so if I multiply here to the 2 and here to the 2 can be written as the 4 divided to the 10, right? These two ratios are the same, are identical, right? So at the same time, it can be written as, if I multiply the original ratios, like a 2 over 5 to the 3. So let me multiply 2 to the 3 and 5 to the 3. It's going to be 6 divided to the 15, right? So the ratios are going to be the same, right? So because it is 2 divided to the 3, this is 5 divided to the 3. You can just always cancel the 2 3's on the numerator and denominator. You're going to have, again, 2 over 5. So at the same time, the second ratio, 2 over 3, can be written when I multiply both of the sides to the 5. So let me multiply 2 to the 5 and 3 to the 5. So in this case, it's going to be 10 divided to the 15, right? And again, so these two rational numbers are the same. So you can just write down any rational number in any form by multiplying both of the sides, numerator and denominator, to the same number. So why we did this? So what I'm going to do is I'm going to substitute 2 over 5 with this one, and I'm going to substitute 2 over 3 with this one because they are the same, right? So let me substitute them. So it's going to be 6 over 15 plus 10 over 15. Voila. So now I've got two rational numbers with a common denominator, with the same denominator. It means that I can use the previous rule and add them. So it's going to be like a 6 plus 10 divided to the 15, so, or 16 divided to the 15. That's a rule, right? Okay. So how to find this common denominator? It's a really important question. So you need to know so-called prime numbers. We're going to talk about this later on in order to find the common denominator. But for now, the easiest rule would be like this. So let's say you've got one rational numbers, p plus q, and another one, a to the b. If you would like to add them, okay, so create the common denominator, and your common denominator, common denominator denominator is always going to be q multiplied to the b. So this is your common denominator, as we did here, right? So this 3 and 5, and our common denominator was the multiplication, 15. So in general, it's going to be like this. The common denominator is q divided to q multiplied to the b. So now we need to make these two ratios with the q multiplied to the b denominators, right? So it's going to be, I multiplied this here to the b, so it's going to be a common denominator. Since I did this with the denominator of the first ratio, I have to do this with the numerator as well. And then I'm going to multiply b here to the q and the numerator of this ratio to the q as well, because I need to keep the balance, right? So the ratio should not change. Okay, so now I've got, so the b multiplied to the p, right, divided to the b multiplied to the q, plus a multiplied to the q divided to the b multiplied to the q. So the denominators are the same, so I can just add these two rational numbers. So one more easy way to remember this, it's going to be p over q plus a divided to the b. So this b goes there, q goes there. So it's going to be p times b plus a times q divided to the b times q. Okay, so let's do one quick example. So let's say 3 over 6, sorry, 2 over 6 plus, let's say, 12 or 11 over 12. Or 11 over, let's say, 7. Okay, so our common denominator is going to be the multiplication of the denominators, which is like 42, right? So I'm going to multiply the 7 to here, 6 to here. It's going to be 7 times 2, which is 14, plus 6 times 11, which is 66, divided to the multiplication, 6 and 7, which is 42. Okay, that's going to be 80 over 42. Cool. So, so hope you understand the idea behind of this addition of the two ratios. So the idea is that we are going to create same denominator in order to use this rule. So this rule is more fundamental for the addition of the ratios, and this rule is basically coming up to this rule. So the second one is we are going to use the first one by just changing changing the form of the numbers. So so this is what I wanted to talk with you in this lecture. Thank you.